Okay, so this is gonna be a chat GPT questionnaire on Unreal Engine 5. I'm gonna ask it questions about blueprints, and we're gonna learn how to do blueprints with chat GPT answering the questions. So let me start this up. Hi, chat GPT.
Hey, how's it going? What's on your mind today?
I want to learn about blueprints.
Awesome! Blueprints in Unreal Engine are super powerful. They're basically a visual scripting system that lets you create gameplay elements without writing code. You can think of them like a flowchart where you connect different nodes to create functionality. Each node represents an action or a function, and by linking them together, you can build everything from character behaviors to complex game mechanics. If you have any specific nodes or features you're curious about, feel free to ask.
Okay, can you talk about delay?
Absolutely. The delay node is a super handy tool in Blueprints. It basically pauses the execution of whatever comes after it for a set amount of time. You can specify this delay duration in seconds. It's perfect for creating timed events like waiting before spawning an actor or adding a short pause in a sequence of actions. One important thing to remember, the delay node only works in event graphs, not in construction scripts. So if you want to add a little breathing room between actions, the delay node is your go-to.
Thank you.
You're welcome. If you want to dive into any other Blueprint nodes or need more details, just let me know.
Okay, now can you talk about timeline node?
Sure thing. The timeline node is another super useful tool in Blueprints. It lets you create animated changes over time, kind of like a mini sequencer. You can use it to smoothly animate properties like movement, color, or rotation. When you open the timeline node, you can add different tracks, float tracks for values that change over time, vector tracks for things like color or location, and event tracks to trigger specific actions at certain points. You can keyframe these tracks to create smooth transitions. For example, if you want a door to open gradually, you could use a timeline to animate the door's rotation over a few seconds. It's a great way to add polish and smoothness to your game's interactions and animations.
Now can you talk about lerp in linear interpolation? Lerp?
Absolutely. The lerp node, which stands for linear interpolation, is a super useful function for blending between two values. It's often used in animations and smooth transitions. The lerp node takes in two values, usually two floats, vectors, or colors, and an alpha value between 0 and 1. The alpha determines how much you blend between the two inputs. For example, if alpha is 0, the output will be the first value. If it's 1, the output will be the second value. If it's zero point 0.5, the output will be exactly halfway between the two. It's great for things like smoothly moving an object from point A to point B, gradually changing a color, or adjusting any property over time. You can even combine it with a timeline node for super smooth animations.
Can you explain the do once node?
For sure. The do once node is a simple but super useful tool. It allows an action or a series of actions to be executed only once, no matter how many times the input is triggered. After it's been triggered once, it won't run again until it's explicitly reset. This is perfect for things like one-time events. Maybe you want a door to open only the first time a player steps on a trigger, or you need a specific sound to play just once. The node has two main inputs, an execution pin and a reset pin. The first time it's triggered, it allows the connected actions to run, but after that, it blocks further execution until you call the reset. This makes it great for controlling one-time behaviors in your game logic.
Now can you explain the gate node?
Absolutely. The gate node is a powerful flow control tool in Blueprints. It acts like a real-world gate, controlling the flow of execution based on whether it's open or closed. Here's how it works. The node has an enter pin, which is the input execution line, and two control pins, open and close. When the gate is open, any execution signal that hits the enter pin will pass through to the exit pin, allowing whatever's connected to it to run. If the gate is closed, the execution is blocked. You can toggle the gate open or closed using the respective pins. There's also a toggle pin that switches the gate state. It's super handy for controlling things like one-time triggers, sequential events, or managing the flow of complex blueprint logic.
Can you explain the flip-flop node?
Of course, the flip-flop node is a neat little control node in Blueprints that alternates between two outputs each time it's triggered. It's super useful for creating simple toggles or alternating behaviors. When you connect an execution line to the flip-flop's input, the first time it's triggered, it will execute output A. The next time, it switches to output B, and then it keeps alternating between the two. This makes it perfect for things like toggling a light on and off, switching between two animations, or controlling a simple two-step sequence. It's a straightforward way to add alternating logic without needing extra variables or complex setups.
Can you explain the sequence node?
Absolutely. The sequence node is a super handy tool for managing multiple execution paths in Blueprints. It allows you to take a single input and split it into multiple output pins that execute in order from top to bottom. For example, if you need to trigger several events in a specific order, like playing a sound, spawning an actor, and then displaying a message, you can use a sequence node to ensure they happen one after another. Each output pin fires in sequence, and you can add as many output pins as you need. This node helps keep your blueprint organized and ensures that complex chains of events happen in the correct order.
Can you explain the branch if statement node?
Absolutely. The branch node, often called an if statement, is one of the most essential nodes in Unreal Engine blueprints. It acts like a decision-making tool that checks a condition and then decides which path to follow. The node has a Boolean input, usually labeled condition. If the condition is true, it executes whatever is connected to the true output pin. If the condition is false, it follows the false output pin. This is perfect for making decisions in your game logic, like checking if a player has enough health to perform an action, determining if an enemy is within range, or deciding which animation to play based on a character's state.
Now can you explain random integer in range node?
Of course, the random integer in range node is a super handy utility for generating random whole numbers within a specified range. You provide it with a minimum and a maximum value, and it will output a random integer between those two numbers inclusive. This node is perfect for adding variety and randomness to your game. For instance, you can use it to spawn enemies at random locations, generate different loot, or create unpredictable behaviors. It's an excellent way to keep gameplay fresh and dynamic by introducing a bit of randomness wherever you need it.
Now can you explain getActorLocation node?
Sure, the getActorLocation node is a super useful function in Blueprints that lets you find out exactly where an actor is in the game world. When you plug an actor reference into this node, it returns that actor's current location as a vector with X, Y, and Z coordinates. This is incredibly handy for all sorts of things, like checking where a player or enemy is, setting a destination for AI, or spawning objects at specific points. If you need to compare distances, move something to a location, or just know where an actor currently is, this node is your go-to.
Now can you explain get forward vector node?
Absolutely. The Get Forward Vector node is a really handy tool for working with an actor's orientation in the game world. It gives you a vector that points in the direction the actor is facing, essentially representing its forward direction. This is super useful for things like moving an actor forward, determining which way a character is looking, or spawning projectiles in the direction the actor is facing. When you use this node, it returns a normalized vector, meaning it has a length of 1, pointing directly forward from the actor. It's great for calculating movement or aligning other objects relative to your actor's orientation.
Now can you explain set visibility node?
Sure, the Set Visibility node is a really useful tool for controlling whether an actor or component is visible in the game world. It's perfect for things like hiding or showing objects, toggling UI elements, or creating stealth mechanics. When you use this node, you'll provide a reference to the actor or component you want to affect. Then you can set its visibility to either true, visible, or false, invisible. There's also an option to affect only the owner, which controls whether child components are also affected. This node is great for creating dynamic environments where objects appear and disappear, or for managing what players can see at any given moment.
Now can you please explain play sound at location node? Play sound at location node?
Sure thing. The Play Sound at Location node is perfect for playing a sound at a specific point in the game world. You just pick a sound asset and provide the location where you want it to play. This node is great for creating immersive audio experiences, like making an explosion sound right where a grenade goes off, playing footsteps at a character's position, or adding ambient sounds to specific locations. You can also set the volume and pitch, giving you even more control over how the sound is played. It's a super versatile way to add spatial audio cues and make your game's world feel more alive.
Now can you please explain add relative rotation node?
Absolutely. The Add Relative Rotation node is a fantastic tool for rotating a component or actor relative to its current rotation. Instead of setting an absolute rotation, it lets you add an offset, which is perfect for things like making a door swing open, rotating a camera, or spinning an object. You provide the node with a rotation value, usually in degrees for pitch, yaw, and roll, and it will adjust the component's rotation based on its current orientation. This is super useful for creating smooth, incremental rotations, like turning a character's head or animating machinery. You can use it on any component with a transform, and it helps keep your rotations nice and relative to the actor's current orientation.
Now can you explain spawn actor from class node?
Definitely. The Spawn Actor from Class node is a super important tool for dynamically creating objects in your game. With this node, you can spawn any actor class at runtime, which means you can create new characters, projectiles, pickups, or any other type of actor whenever you need them. To use this node, you specify the class of the actor you want to spawn, and then provide a location and rotation for where it should appear. You can also set optional parameters like scale or collision handling. This node is perfect to creating gameplay elements on the fly, whether you're spawning enemies during a wave, dropping loot from a defeated enemy, or placing objects in response to player actions.
Now can you explain destroy actor node?
Absolutely. The Destroy Actor node is a straightforward but powerful tool in Blueprints that allows you to remove an actor from the game world. When you call this node on an actor, it completely destroys that actor instance, removing it from the level. This is super useful for things like destroying enemies when their health reaches zero, removing projectiles after they've hit something, or cleaning up temporary objects to keep your game running smoothly. Just be careful with it. Once an actor is destroyed, it's gone for good. So make sure you're not destroying something you still need.
Now can you please explain apply damage node?
Sure, the apply damage node is a crucial part of handling damage in Unreal Engine. It lets you deal damage to an actor, which is super useful for things like combat, environmental hazards, or any situation where you need to affect an actor's health. You provide the node with the actor that will receive the damage amount, and optionally the instigator, who caused the damage, and the damage causer, like a projectile or weapon. The engine then takes care of applying the damage, triggering any relevant events like any damage on the affected actor. This node makes it easy to create complex damage systems while keeping everything modular and organized.
Now can you explain line trace by channel node?
Absolutely. The line trace by channel node is a super versatile tool for detecting objects in a straight line, kind of like a laser pointer. It sends out an invisible line from a start point to an end point and returns information about anything it hits along the way. This node is perfect for things like shooting mechanics, line of sight checks, or detecting if there's an obstacle between 2 points. You can also choose which collision channel to use, allowing you to customize what types of objects the line trace will interact with. If the line hits something, it returns a hit result, giving you details like the location, the normal of the surface, and the actor that was hit. This makes it incredibly useful for all kinds of interactive gameplay elements.
Now can you explain set timer by function name node?
Absolutely. The set timer by function name node is a super useful tool for scheduling functions to run after a delay or repeatedly at set intervals. It's perfect for creating timed events without needing to use tick or constantly checking conditions. You specify the name of the function you want to call, set the time delay, and choose whether the timer should loop. Once the timer is up, it automatically calls the specified function. This node is great for things like cooldowns, delayed actions, or repetitive tasks. Plus, you can clear or pause the timer if needed, giving you a lot of flexibility for managing timed events in your game.
Now can you explain cast to casting node?
Absolutely. The Cast To node is essential for working with different object types in blueprints. It allows you to convert a generic reference into a more specific type so you can access that object's unique properties and functions. See, for example, if you have a reference to a general actor but need to access something specific to a character, you can use a Cast To Character node. If the cast is successful, you can then work with the character-specific properties and methods. If the cast fails, it means the object isn't of the type you're casting to, so it's always good to handle that case. This node is crucial for ensuring you're working with the correct object type and accessing the right functionality.
Can you please say these blueprint nodes will help with movement, interaction, timing, randomization, game logic?
Absolutely. These blueprint nodes are fundamental building blocks for all sorts of game mechanics. For movement, nodes like add relative rotation and get forward vector help control how your actors move and face different directions. For interaction, nodes like line trace by channel let you detect objects and create responsive gameplay. For timing, set timer by function name is great for scheduling actions, while random integer in range helps with randomization. For game logic, nodes like branch, do once, and sequence help you control the flow of your game, making decisions and managing events. By combining these nodes, you can create complex and engaging gameplay systems.
Alright, repeat after me. There are 20 more blueprint nodes that haven't been mentioned yet.
Got it. There are 20 more blueprint nodes that haven't been mentioned yet.
Now can you please explain Get Player Controller node?
Absolutely. The Get Player Controller node is super useful for accessing the player's controller in your game. The player controller is responsible for handling player input and controlling the pawn or character. When you use this node, you can specify which player you want to get the controller for, usually the first player indexed as 0. Once you have the player controller, you can use it to access player inputs, manage camera controls, or even trigger HUD elements. This node is essential for setting up player interactions and controlling the main character or pawn in your game.
Okay, now can you explain Get Player Character node?
Of course, the Get Player Character node is super handy for quickly accessing the character controlled by the player. It gives you a reference to the player's character in the game world, which you can then use to access its properties and functions. See, typically, you'll specify the player index, usually 0 for the first player. Once you have this reference, you can control the character, modify its variables, or trigger specific actions like jumping or attacking. This node is great for setting up player-specific functionality, making it easy to interact with the main character directly.
Can you explain some examples like position and health?
Absolutely. With the Get Player Character node, you can easily access and manipulate key aspects of the player's character. For example, if you want to adjust the character's position, you can use nodes like Set Actor Location or Add Movement Input to move the character around the world. This is great for teleporting the player or creating custom movement behaviors. For health, you can usually access the player's health variable through the character's blueprint. By using a cast to node, you can cast the generic character reference to your specific character class and then get or set the health value. This lets you implement health pickups, damage systems, or health regeneration. By accessing these properties, you can create custom gameplay mechanics that make your game more interactive and engaging.
Thank you.
You're welcome. If you need more help with blueprints or anything else, just let me know.
Can you please explain the Get Control Rotation node? Get Control Rotation node?
Absolutely. The Get Control Rotation node is super useful for getting the rotation of the player's controller, which often determines where the player is looking. This is especially important for first-person and third-person games where the camera or aiming direction is controlled by the controller. When you use this node, it returns a rotator value representing the controller's current orientation. This is great for aligning a character's movement or attacks with the direction the player is looking. For example, you can use the control rotation to make sure your character faces the same way as the camera or to determine the direction of a line trace or projectile.
Now can you explain Set Actor Hidden in Game?
Of course, the Set Actor Hidden in Game node is a simple but powerful way to control an actor's visibility during gameplay. When you use this node, you can toggle whether an actor is visible or hidden in the game world. If you set it to true, the actor becomes invisible but still exists in the scene, meaning it can still interact with other objects, trigger collisions, or be detected by line traces. If you set it to false, the actor will be visible again. This is great for creating stealth mechanics, temporary disappearances, or managing objects that need to be hidden without destroying them.
Can you please explain add local offset node?
Absolutely. The add local offset node is super handy for moving an actor or component relative to its local coordinate system. Instead of moving it in world space, it shifts the actor along its own local axes, X, Y, or Z. This is great for creating smooth relative movements, like making a platform slide or a character move forward based on its current orientation. You provide a vector input that defines the movement direction and distance. For example, adding a local offset of 10, 0, 0 moves the actor 10 units forward along its local x-axis. This node is perfect for fine-tuning movement, especially for objects that need to move in relation to their current notation or position.
Can you explain clamp, clamp float, clamp int, and clamp vector nodes?
Absolutely. The clamp nodes are super useful for ensuring values stay within a specific range. Clamp float, this node takes a float, a decimal number, and makes sure it stays within a minimum and maximum range that you define. For example, if you have a player's health that shouldn't drop below 0 or go above 100, you can use this node to keep it in that range. Clamp int, similar to clamp float, but for integers, whole numbers. This is perfect for things like keeping a score or inventory count within a certain limit. Clamp vector, this node ensures each component, x, y, and z, of a vector stays within specified minimum and maximum values. This is great for constraining movement within a certain area or keeping an object within bounds. See, these nodes are essentially for maintaining control over your variables and preventing them from going out of range.
Now can you explain break vector node?
Absolutely. The break vector node is a super handy tool for taking a single vector and splitting it into its individual components, x, y, and z. This is especially useful when you need to work with or manipulate each axis separately. For example, if you have a vector representing a location or direction, you can use the break vector node to get the individual x, y, and z values. This is perfect for scenarios where you might want to clamp only the height, z-axis, or adjust just the x and y coordinates. See, by breaking a vector, you can easily perform operations on its individual components before recombining them with a make vector node.
Okay, now explain make vector node.
Sure, the make vector node is essentially the opposite of the break vector node. It allows you to create a new vector by combining individual x, y, and z values. This is super useful when you have separate float values and you want to combine them into a single vector. For example, if you have separate values for an object's forward, right, and up movements, you can use make vector to combine them into a single movement direction. It's also great for setting locations or directions by specifying each axis individually. This node is perfect for reconstructing vectors after performing operations on individual components.
Now explain normalize vector node.
Absolutely. The normalize vector node is a super useful tool for working with directional vectors. What it does is take any vector and convert it into a unit vector, meaning it keeps the same direction, but its length or magnitude is set to 1. This is incredibly handy for situations where you need a consistent direction but don't want to worry about the vector's length. For example, if you're calculating movement direction or applying force, normalizing the vector ensures that the intensity remains consistent. It's a must-have for anything involving direction, helping you keep calculations clean and predictable.
Now explain find look at rotation node.
Absolutely. The find look at rotation node is a fantastic tool for making one actor or object rotate to face another. It calculates the exact rotation needed for an actor to look directly at a target point. You provide it with a starting location, usually your actor's position, and a target location, the object or point you want to face. The node then outputs a rotator, which you can use to set the actor's rotation. This is perfect for things like making a turret aim at a target, having a character look at an object, or orienting a camera to focus on something specific.
Okay, now add a now explain the add controller yaw input node. Add controller yaw input node.
Absolutely. The add controller yaw input node is perfect for rotating a player-controlled character or pawn around its vertical axis, which is typically used for turning left and right. When you call this node, it adds a specified amount of yaw, rotation around the z-axis, to the controller, which then rotates the character accordingly. This is super useful in first-person or third-person games for smooth, responsive camera control. It's often tied to player input, like moving the mouse or pressing a controller stick to let the player look around naturally. It's a key part of creating fluid, intuitive movement for player-controlled characters.
Now explain add controller pitch input node.
You got it. The add controller pitch input node is used to control the up and down rotation of a player-controlled character or camera, often used for looking up and down. When you call this node, it adds a certain amount of pitch, rotation around the y-axis to the controller, which then tilts the character or camera up or down. This node is crucial for implementing smooth and responsive vertical camera control, especially in first-person and third-person games. It's often connected to player input, like mouse movement or a gamepad's right stick, to give players full control over their view. It's an essential part of making camera and character movement feel natural and intuitive.
Okay, now explain finterp2.
Sure, the finterp2 node is super useful for smoothly interpolating between two float values over time. It's perfect for creating smooth transitions, like gradually changing a light's intensity, a door's position, or a character's speed. You provide it with a current value, a target value, and a delta time, usually from the tick event, along with an interpolation speed. The node will then return a new value that's closer to the target, creating a natural easing motion. It's a fantastic way to add polish and smoothness to your game mechanics without having to manually calculate every step.
Now explain vinterp2 node.
Sure, the vinterp2 node is very similar to finterp2, but it works with vectors instead of slopes. This node smoothly interpolates between two vector values over time, making it perfect for gradually changing positions, directions, or any other vector-based values. You provide it with a current vector, a target vector, delta time, usually some tick, and an interpolation speed. The node will move the current vector closer to the target vector each tick, creating a smooth, natural transition. This is great for things like moving objects smoothly or interpolating between 2 points over time.
Okay, now explain switch on int node.
Sure, the switch on int node is a super useful way to create branching logic based on an integer value. Think of it like a switch statement in programming. You feed it an integer and it will execute different outputs depending on the value of that integer. For example, if you have a variable representing the current state of a game, you can use switch on int to perform different actions based on that state. If the integer is 0, it might mean the game is in a menu. If it's 1, the game is playing. And if it's 2, the game is paused. It's a great way to keep your blueprint logic organized and easy to follow.
Okay, now explain switch on enum. Switch on enum node.
Of course, the switch on enum node is similar to switch on int, but it works with enumerations, enums, instead of integers. Enums are custom variable types that let you define a set of named values, making your code more readable and organized. When you use switch on enum, you can execute different execution paths based on the value of the enum. For example, if you have an enum representing different game states like idle, running, jumping, or attacking, you can use this node to trigger different behaviors for each state. This is a fantastic way to manage complex logic, especially when dealing with multiple states or modes in your game.
Now explain retriggerable delay. Retriggerable delay node.
Absolutely. The retriggerable delay node is a handy tool for creating a delay that can be reset if it's triggered again before it finishes. You set a duration, and when the node is triggered, it starts a countdown. If it gets triggered again before the delay is complete, it restarts the timer. This is perfect for scenarios where you want to ensure a certain amount of time passes without interruption before an action occurs. For example, you could use it for a timer that resets if a player keeps performing an action, ensuring that the delay only completes when the action stops for the full duration.
Okay, now can you explain the isValid node?
Sure, the isValid node is a super useful tool for checking whether an object reference is valid before you try to use it. It helps prevent null reference errors by making sure that the object or pointer you're working with actually exists. When you pass an object into the isValid node, it has 2 output pins, one for when the object is valid and another for when it's not. This lets you create branching logic to handle both cases safely. It's a simple but powerful way to ensure your blueprints run smoothly without unexpected errors.
Now can you explain set timer by event node?
Absolutely. The set timer by event node is a powerful tool for scheduling events to happen after a certain amount of time. Instead of specifying a function name, you directly connect an event, which gives you more flexibility. You can set the time delay and choose whether the timer should loop. Once the timer completes, the connected event will execute. This is great for creating custom, reusable timers that can trigger blueprint events directly. It's perfect for things like cooldowns, delay actions, or repeating behaviors, and it gives you a lot of control over when things happen in your game.
Can you explain get world delta seconds node?
Absolutely. The Get World Delta Seconds node is an essential tool for any time-based calculations in Unreal Engine. It returns the time in seconds that has elapsed since the last frame, also known as the frame delta time. This node is crucial for ensuring that movements, animations, and other time-sensitive operations remain consistent, regardless of the frame rate. For example, if you're moving an object, you multiply its speed by get world delta seconds to ensure it moves smoothly over time. In short, it helps make everything frame rate independent, ensuring consistent behavior across different hardware.
Can you explain that these nodes cover game controls, movement, logic flow, and optimization?
Absolutely. These nodes cover a wide range of essential functions in game development. Game controls, nodes like add controller yaw input and add controller pitch input are crucial for player camera control, allowing smooth and responsive movement. Movement, nodes like add local offset, vinterp2, and get forward vector help manage smooth and consistent movement of characters and objects. Logic flow, nodes like branch, do once, gate, flip-flop, sequence, switch on int, and switch on enum are key for controlling the flow of your game's logic, making sure the right actions happen at the right times. Optimization, get world delta seconds, ensures your game runs smoothly across different frame rates, while nodes like retriggerable delay and set timer by event help manage timing efficiently. Together, these nodes provide a solid foundation for building robust, responsive, and well-optimized gameplay systems.
Repeat after me. Sure, here are 20 more blueprint nodes that haven't been mentioned yet.
All right, sure, here are 20 more blueprint nodes that haven't been mentioned yet.
Can you please explain set actor enable collision?
Of course, the Set Actor Enable Collision node allows you to toggle an actor's collision on or off. When you enable collision, the actor can interact physically with other objects in the world, meaning it can block, overlap, or trigger events based on its collision settings. When you disable it, the actor will no longer interact physically with other objects, essentially making it ghost through them. This is super useful for things like temporarily disabling collisions during animations, cutscenes, or when you want an actor to pass through another object without interference.
Can you please explain set simulate physics node?
Absolutely. The Set Simulate Physics node is used to enable or disable physics simulation on an actor or component, like a static mesh or a skeletal mesh. When you enable physics simulation, the object will start behaving according to the physics engine, meaning it can respond to gravity, collisions, and other forces. This is perfect for making objects fall, roll, or interact realistically with their environment. If you turn it off, the object will no longer respond to physics and can only be moved by direct transformations. It's a great way to add realism to your game by letting objects behave naturally within the game world.
Can you explain get hit result under cursor? node?
Absolutely. The get hit result under cursor node is a super handy tool for detecting what the player's mouse cursor is currently pointing at in the game world. When you call this node, it performs a line trace or raycast from the cursor's position on the screen into the game world and returns information about the first object it hits. This is perfect for implementing point-and-click interactions like selecting objects, moving characters, or placing items in a strategy game. The node gives you detailed hit results, including the location, the actor that was hit, and the surface normal, making it easy to create intuitive player interactions.
Okay, can you explain get hit result under finger?
Absolutely. The get hit result under cursor node is similar to the get hit result under cursor node, but it's specifically designed for touch input on mobile devices. Instead of using the mouse cursor, this node detects what a player's finger is touching on the screen. When you use this node, you specify which finger index to check, like the first or second finger. The node then performs a line trace from the touch position into the game world, returning details about the first object it hits, including the location, actor, and surface normal. This node is perfect for creating touch-based interactions in mobile games, letting you easily implement tap to select, drag and drop, or any other touch interactions.
Can you explain add radical force node?
User wants detailed explanations for the add radial force node in Unreal Engine blueprints. Of course, the add radial force node is used to apply an outward force from a specific point in the game world, creating an explosion-like effect. When you use this node, it pushes any physics-simulated objects within a specified radius away from the center of the force. You can control the strength of the force, the radius, and whether it affects objects only within line of sight. This is perfect for creating explosive effects like grenades or shockwaves that push nearby objects away realistically. It's a fantastic way to add dynamic and dramatic physics interactions to your game.
Can you explain add radical damage?
Definitely. The add radial damage node is used to apply damage in a spherical area around a specific point. It's perfect for simulating explosive damage, like from grenades or bombs. When you use this node, you specify the damage amount, the origin point, and the radius of the damage area. Any actors within that radius can receive damage, and you can also set it to ignore certain actors or apply falloff, meaning the damage decreases with distance from the center. It's a great way to create realistic area of effect damage that impacts multiple actors at once.
Can you explain get actors of all class?
Of course, the Get All Actors of Class node is a super useful tool that allows you to find and collect all instances of a specific actor class in your level. When you use this node, you specify the actor class you're looking for, and it returns an array containing all actors of that class currently in the level. This node is fantastic for scenarios where you need to interact with or manipulate multiple actors of the same type, like finding all enemies, pickups, or checkpoints. Once you have the array, you can loop through it and perform actions on each actor, making it a powerful tool for managing large groups of objects.
Can you explain get closest actor node?
I'm not seeing a specific blueprint node called Get Closest Actor in Unreal Engine. However, you can achieve this functionality by using the Get All Actors of Class node to gather all actors of a certain type and then iterating through them to find the one closest to a reference point. Typically, you'd compare the distances between your reference actor and each actor in the array, storing the one with the shortest distance. This approach is super useful for things like finding the nearest enemy, item, or objective, allowing your game logic to react dynamically based on proximity.
Thank you.
You're welcome. If you have any more questions or need more details, just let me know.
Okay, can you explain attached to actor node?
Absolutely. The attached to actor node is used to attach one actor to another, making the attached actor move, rotate, and scale relative to its parent. This is super useful for creating complex objects or hierarchies, like attaching a weapon to a character's hand or mounting a camera to a vehicle. With this node, you can specify the attachment rules for location, rotation, and scale, allowing you to control whether the attached actor maintains its world transform or adopts the parent actor's transform. It's a powerful way to create dynamic, modular setups where different components can be easily combined and controlled.
Okay, can you explain detach from actor?
Sure, the detach from actor node is used to separate an actor from its parent, effectively removing any attachment. Once detached, the actor regains its independence, meaning its position, rotation, and scale are no longer controlled by the former parent actor. You can also specify rules for how the actor should behave, as whether it maintains its world position or snaps back to its original location. This node is great for gameplay mechanics where you need objects or characters to attach and detach dynamically, like dropping a weapon, releasing a carried object, or unmounting from a vehicle.
Can you explain set material node?
Absolutely. The get hit result under cursor node is used to attach one actor to another, making the attached actor move, rotate, and scale relative to its parent. For example, you can use it to change a character's outfit, switch the color of an object, or apply a special effect like a glowing outline. You simply specify the mesh you want to modify, choose the material slot index if the mesh has multiple materials, and then provide the new material. It's a great way to add variety and responsiveness to your game's visuals.
Can you explain that a little simpler?
Sure, the set material node lets you change how an object looks while the game is running. For example, you can switch a character's clothing or change a car's paint color. You just pick the object, select which part of it to change if it has multiple parts, and then choose a new material. It's a simple way to update the appearance of things in your game.
I'm sorry, but you've hit the daily limit for advanced voice. You can switch to standard now to keep chatting.
Can you explain in Unreal Engine set scalar parameter value?
Sure. The Set World Scale 3D and Set Relative Scale 3D nodes in Unreal Engine allow you to change the size of an actor or component in the game. 1. Set World Scale 3D. This node changes the scale of an object based on world space, meaning it ignores the parent actor's scale. If you set an object's scale to 222, it will be twice its original size globally. Useful when you want an object to have a fixed scale in the world, no matter where it is attached. 2. Set relative scale 3D. This node changes the scale relative to its parent object if it's attached to one. If a child object has a scale of 1, 1, 1, it will match its parent size. If you set it to 2, 2, 2, it will be twice the size of its parent. When to use them? Set world scale 3D is best for standalone objects. Set relative scale 3D is great for objects that need to scale with their parent, like attachments or modular pieces. Would you like an example of how to use it in blueprints?
Can you explain the Unreal Engine play animation node?
Sure. The play animation node in Unreal Engine is used to play an animation sequence on a skeletal mesh. This is great for simple animation playback without needing a full animation blueprint. Here, how it works. You connect a skeletal mesh component to the node, like a character or object with a skeleton. Select an animation sequence from your assets. When executed, the animation plays on the given mesh. Key options. Looping. If checked, the animation repeats continuously. Play rate controls the speed of playback. 1.0's normal speed, 0.5 half speed, 2.0's double speed. Starting position lets you start the animation from a specific point. Hasha, when to use it. For one-time animations, like opening a door, pressing a button, or a character reaction. When you don't need complex animation blending from an animation blueprint. Limitations. It doesn't allow smooth blending between animations. It's best for single actions, not full character movement. For more advanced control, you'd use an animation blueprint with a state machine. Want me to explain that too?
No, now explain stop animation node.
Sure. The stop animation node in Unreal Engine is used to halt an animation playing on a skeletal mesh component. How it works. You provide a skeletal mesh component like a character or animated object. When this node is executed, it immediately stops the currently playing animation. The mesh will stay in the last frame of the animation unless another animation is applied. Hashard, when to use it. If you want to cancel an animation before it finishes, e.g. stopping a door from fully opening, when switching from one animation to another abruptly. For interactions where a player or event interrupts an animation, like stopping an NPC's action if they get attacked. Key considerations. It only works on animations started with play animation, not through an animation blueprint. If you need smooth transitions, it's better to blend animations inside an animation blueprint instead of stopping them instantly. Would you like an example of how to use it in blueprints?
No, can you explain play sound 2D node?
Sure. The Play Sound 2D node in Unreal Engine is used to play a sound that is not affected by 3D positioning. This means the sound will play at the same volume and clarity, no matter where the listener, camera, or player is in the world. How it works. You select a sound asset, like a sound effect or music track. When the node is triggered, the sound plays instantly. Unlike play sound at location, it does not consider distance, direction, or spatial positioning. When to use it. Music and UI sounds, great for background music or button click sounds. Notifications, useful for global alerts, like a level up sound. Dialogue ambience can be used for narrator voice lines or ambient music. Key considerations. If you need spatialized audio, where sound change-in is based on distance or direction, use play sound at location instead. You can control volume, pitch, and looping inside the sound cue or audio component. Would you like an explanation of how to use it dynamically in a blueprint?
Explain to me what apply point damage node is.
Sure. The Apply Point Damage node in Unreal Engine is used to apply damage to an actor at a specific location, making it perfect for things like bullet impacts or melee hits. How it works. You specify Damaged actor, the actor receiving the damage. Damage amount, how much damage to apply. Hit from direction, the direction the damage came from, useful for knockback effects. Hit info, a structure containing details like the hit location and surface normal. Damage causer, the object responsible for the damage, e.g. a bullet or sword. Event instigator, the controller responsible for the attack, e.g. the player or AI. When executed, it calls the event any damage and event point damage on the damaged actor, allowing you to handle the effect, like reducing health, playing effects, or triggering destruction. When to use it. For precise damage application, like shooting an enemy where the bullet hits. When you need directional damage, such as calculating hit reactions or knockback. For destructible objects, like breaking glass only at the impact point. Key considerations. If you don't need a specific hit location, use apply damage instead. Works well with line trace by channel for raycast-based weapons. Would you like an example of how to use it with a hit detection system?
No, explain to me enable input node.
Sure, the Enable Input node in Unreal Engine allows an actor to receive player input. Normally, only the player's controlled actor, like the character or pawn, gets input, but this node lets any actor listen for input events. How it works. You provide target, the actor you want to enable input for. Player controller, the controller that will send input, usually the player's controller. Once enabled, the actor can detect key presses and execute events like on key pressed. When to use it. Interacting with objects allows doors, levers, or computers to detect player input. Custom controls lets actors react to key presses without needing to be a pawn. Cutscenes or special modes temporarily enables input for objects during scripted sequences. Key considerations. If an actor has enable input, it might steal inputs from the player's main character. You may need to use disable input when the interaction is over. Works best when combined with UI prompts to show the player when they can interact. Would you like an example of how to use it in an interaction system?
No, explain to me disable input.
Sure, the disable input node in Unreal Engine is used to stop an actor from receiving player input after it has been enabled. How it works. You provide target, the actor you want to disable input for, player controller, the controller that was previously enabled for input. When executed, the actor will no longer respond to input events like key presses or mouse clicks. When to use it. After an interaction is complete, like when a player stops using a door, computer, or lever. For cutscenes, where you want to disable input to prevent the player from moving or interfering. For temporary control changes, like switching between characters or restricting input in menus. Key considerations. It only works if the actor previously had enable input activated. Make sure you re-enable input when needed to avoid leaving the player unable to interact. Works well when paired with enable input for interactive objects. Would you like an example of how to use it in an interaction system?
No, that's okay.
Got it. If you ever need more blueprint explanations, just let me know.
Can you explain add relative location blueprint?
Sure. The Add Relative Location node in Unreal Engine moves an actor or component by a certain amount relative to its parent object. How it works. You specify target, the actor or component you want to move. Delta location, a vector XYZ that determines how much to move the object. Sweep, if enabled, Unreal will check for collisions before moving. Teleport, if enabled, the movement happens instantly without physics interference. Have when to use it. For local movement, like making a platform slide forward without changing world position. For attachments, like moving a gun slightly forward while it stays attached to a character. For smooth motion, such as shifting an object over time without needing physics. Key considerations. Moves relative to the parent, so if the parent rotates, the movement follows that direction. If you want world space movement, use add world location instead. If you need continuous movement, use it in tick or with a timeline. Would you like an example of how to use it in a blueprint?
No, that's okay.
Got it. If you ever need more blueprint explanations, just let me know.
Explain to me save game to slot blueprint.
Sure. The Save Game to Slot node in Unreal Engine allows you to store game data permanently so that it can be loaded later. How it works. 1. Create a save game object. Before saving, you need a save game class with variables to store like player health, position, or inventory. 2. Set data. Fill the save game object with the data you want to save. 3. Save to slot. Provide save game object the data you're saving. Slot name, a string that identifies the save file. User index, usually 0, used for multiple user profiles. 4. Execution. When triggered, this node writes the data to disk. When to use it. Saving progress, like level completion or character stats. Storing player settings, such as audio volume or key bindings. Creating multiple save slots, allowing different game states. Key considerations. Works best with load game from slot to retrieve saved data. Be sure to call "Does save game exist?" before loading to check if a save file is available. If you overwrite a save, old data is lost. Use multiple slots if needed. Would you like an example of how to set up a save system?
Repeat after me. These nodes help with the interaction, physics, animation, audio, damage, and saving data.
These nodes help with interaction, physics, animation, audio, damage, and saving data.
Repeat after me. Here are 20 more blueprint nodes that haven't been mentioned along with the explanations.
Here are 20 more blueprint nodes that haven't been mentioned along with the explanations.
Explain to me set actor enable collision.
It looks like you're asking about set active and set enable collision in Unreal Engine. These are two separate nodes that work with components. GIN, set active node. This enables or disables a component like a light or particle system. If set to false, the component is deactivated but not removed, useful for turning objects on-off without destroying them. 2. Set enable collision node. This enables or disables collision for an actor or component. If true, the object can block or overlap other objects. If false, it becomes non-collidable, other objects pass through it. Great for toggling collision on interactive objects. Common use cases. Temporarily disabling physics objects, like a door that becomes passable after opening. Turning off collision for performance reasons when an object isn't needed. Controlling whether an item can be picked up by enabling, disabling collision. Would you like a specific example in blueprints?
Explain to me set simulate physics node.
Sure. The Set Simulate Physics node in Unreal Engine enables or disables physics simulation on an object. How it works. You target the static mesh or skeletal mesh component to apply physics to. Simulate a Boolean true or false to turn physics on or off. When enabled true, the object is controlled by Unreal's physics engine, meaning it will be affected by gravity. It can be pushed or collide with other objects. Forces like add impulse or add force will work on it. When disabled false, the object is no longer physics-driven and can only be moved manually using set location rotation. When to use it. Making objects dynamic, like dropping a box that starts falling. Switching between static and physics-driven states, like freezing an object in place. Simulating ragdoll physics, for example, making a character collapse when defeated. Key considerations. Make sure the object has simulate physics enabled in the editor if you want it to work at runtime. If an object is part of a hierarchy, enabling physics might detach it from its parent. Would you like an example of using this in a blueprint?
No, that's okay. Explain to me get hit result under cursor node.
You already asked about get hit result under cursor, and I explained that it performs a line trace from the mouse cursor to detect objects in the game world. If you need a refresher or more details, just let me know.
Explain to me get hit result under finger.
Sure. The get hit result under finger node in Unreal Engine is used to detect what an object a player is touching on a mobile or touchscreen device. Matter how it works. It performs a line trace raycast from the point where the player touches the screen into the 3D game world. You provide finger index, specifies which finger, like thumb 1, thumb 2, etc. Trace type defines what kind of objects the trace should detect, e.g. visibility or physics. It returns a hit result containing actor hit, what object was touched. Impact location, where on the object the touch landed. Surface normal, useful for angle-based interactions. When to use it. Tap to move mechanics, like clicking to move a character. Touch-based object selection, such as picking up items. Interacting with world objects, like opening doors or pressing buttons. Key considerations. Works only on touchscreen devices. Make sure collision settings on objects allow traces to detect them. Can be combined with UI elements to determine whether the player is tapping the world or an interface. Would you like an example of how to use it for mobile interaction?
Explain to me add radical force node.
It looks like you meant add radial force in Unreal Engine.
Yes.
This node applies an explosion-like force that pushes objects outward from a center point. How it works. You provide target, the component receiving the force, usually a physics-enabled object. Origin, the center of the force, where the explosion happens. Force strength, how powerful the push is. Radius, the area affected by the force. Fall off, whether the force weakens over distance. Impulse option, if checked, the force applies instantly instead of over time. When to use it. Explosions, pushing nearby objects outward. Shock waves, creating a blast effect in a game. Area of effect physics interactions, like wind blasts. Key considerations, only affects objects with simulate physics enabled. Works well with add radial damage for explosive effects. If objects don't move, check their mass settings. Heavy objects may need more force. Would you like an example of how to use it in blueprints?
Explain to me add radial damage.
It looks like you might be asking about something related to damage in Unreal Engine, but Adwaita yield damage doesn't seem to match any known blueprint nodes. Could you clarify what you mean? If you're referring to applying damage, I can explain nodes like apply damage for general damage handling, apply point damage for precise hit locations like bullets, apply radial damage for area-based damage like explosions. Let me know what you're looking for, and I'll break it down for you.
Explain add radial damage.
It looks like you meant add radial damage in Unreal Engine. This node applies damage in a circular area around a specified point, making it perfect for explosions, shockwaves, or area of effect attacks. How it works. You provide base damage, the maximum damage applied at the center. Origin, the location where the damage happens. Damage radius, how far the damage spreads from the center. Damage type, used to apply specific damage effects, e.g. fire, poison, explosion. Ignore actors, lets you exclude certain actors from taking damage. Fall off, determines if damage decreases with distance from the center. When to use it. Explosions, where damage affects everything in a radius. Shockwaves, damaging multiple enemies at once. Area-based attacks like a magical blast or earthquake effect. Key considerations. Works best with apply radial force to push objects alongside dealing damage. If actors don't take damage, check their collision settings and ensure they have an event any damage or event radial damage in their blueprint. If fall off is 0, all targets in range take full damage. If it's higher, damage weakens with distance. Would you like an example of how to set up an explosion effect using this?
Explain to me get all actors of class node.
Sure. The Get All Actors of Class node in Unreal Engine finds and returns an array of all actors of specific class that exist in the level. Next, how it works. You provide actor class, the type of actor you want to find, e.g. all enemies, all pickups, all doors. The node returns an array of actors of the specified class. When to use it. Finding all enemies in the level for AI logic. Checking all pickups to see if the player has collected everything, interacting with multiple objects, like turning off all lights at once. Key considerations can be performance heavy if used frequently, better to use sparingly or store results in a variable. If there are no actors of the class in the level, the array will be empty. Works great when used with loops to perform actions on each found actor. Would you like an example of how to use it in a blueprint?
Explain to me get closest actor node.
There isn't a Get Closest Actor node by default in Unreal Engine, but you can achieve this using Get All Actors of Class and looping through the results to find the nearest one. How to find the closest actor. 1. Use Get All Actors of Class to collect all actors of a certain type. 2. Loop through the array and compare distances between each actor and your reference point, e.g. the player. 3. Keep track of the closest one by checking which has the smallest distance. Blueprint steps. Step 1. Get all actors of a certain class, e.g. all enemies. Step 2. Set a variable to store the closest actor. Step 3. Use a for each loop to check the distance of each actor. Step 4. Compare distances and update the closest actor if needed. Example logic. You can see the code in our conversation history. When to use it. Targeting the nearest enemy in a combat system. Finding the closest health pack when the player is low on health. Selecting the nearest interactable object dynamically. Key considerations. If there are no actors in the level, make sure to check for a valid result before using it. Running this every frame could affect performance. Try caching the closest actor instead. Would you like a detailed blueprint example?
Explain to me attached to actor node.
Sure. The Attach to Actor node in Unreal Engine is used to attach one actor to another so they move together. How it works, you provide target, child actor, the actor you want to attach. The actor it will attach to, socket name, optional, a named attachment point on the parent, e.g. a weapon socket on a character's hand. Attachment rules. Keep world transform. The child keeps its original position rotation. Snap to target. The child moves to the exact position of the parent. Keep relative transform. The child keeps its position relative to the parent. Taverge, when to use it. Equipping weapons items, e.g. attaching a sword to a character's hand. Mounting objects, like a character getting on a horse or a spaceship docking. Attaching cameras or effects, like a spotlight following a character. Key considerations. If you need to detach later, use the Detach from Actor node. If using physics, the attached object might need Set Simulate Physics turned off. Works best when attaching objects to predefined sockets on skeletal meshes. Would you like an example of how to attach a weapon to a character's hand?
Explain to me detach from actor node.
Sure. The Detach from Actor node in Unreal Engine is used to remove an attachment, allowing an actor to move independently again. How it works. You provide child actor, the actor that should detach from its parent. When executed, the child stops following the parent and becomes separate in the world. Optional detachment rules. Keep world transform. The actor stays in its current position. Snap to target. moves the actor to the parent's exact position before detaching. Keep relative transform keeps the actor's position relative to the parent before detaching. When to use it. Dropping weapons items from a character's hands. Unmounting a player from a vehicle. Releasing objects from a physics grab system. Key considerations. If the object was using physics, you may need to re-enable physics with set simulate physics after detaching. Works best with attach to actor for dynamic attachments. You can also detach components instead of full actors using detach from component. Would you like an example of detaching an object after an interaction?
Explain set material node.
Sure. The set material node in Unreal Engine is used to change the material on a mesh during gameplay. How it works. You provide target mesh component, the object whose material you want to change. Material index. If the mesh has multiple materials, choose which one to replace. New material, the material you want to apply. When to use it. Changing character skins or armor dynamically. Switching object appearances, like turning a door rusty or a light glowing. Creating effects, such as a power-up changing a player's look. And key considerations. If the material has dynamic parameters, like color changes, use Create Dynamic Material Instance instead for real-time adjustments. The material must be compatible with the mesh. Some materials are made for specific objects. Works well with interactions, like clicking a button to swap materials. Would you like an example of changing a character's outfit in Blueprints?
Explain to me set scalar parameter value. Set scalar parameter
Sure.
value.
The set scalar parameter value node in Unreal Engine is used to change a scalar single float parameter in a material instance dynamic at runtime. This is useful for modifying materials dynamically, like adjusting opacity, glow intensity, or animation speed. How it works. 1. Create a material parameter. In your material, use a scalar parameter instead of a constant value. Name the parameter, e.g. glow intensity or opacity. 2. Use the set scalar parameter value node, target, a material instance dynamic, not a regular material. Parameter name, the exact name of the scalar parameter in the material. Value, a float value to update the parameter in real time. When to use it. Changing brightness of an object dynamically. Controlling transparency, e.g. making a ghost fade in-out. Adjusting animation speed in a shader. Modifying emissive glow in neon signs or UI effects. Key considerations. You must use a material instance dynamic, created using Create Dynamic Material Instance. The parameter name must match exactly as it appears in the material editor. If the material doesn't update, check if the object is using the correct material instance. Would you like an example of how to use this for a glowing effect?
Explain to me play animation node.
Sure. The Play Animation node in Unreal Engine is used to play a specific animation on a skeletal mesh component during gameplay. How it works. You provide target skeletal mesh component, the character or object that will play the animation. Animation to play a selected animation sequence, e.g. a walk or attack animation. Looping, true false, whether the animation repeats continuously. The play rate, adjust the speed 1 normal speed, 2 double speed. Starting position, allows the animation to start at a specific time instead of the beginning. When to use it, triggering animations for NPCs like waving or sitting. Playing one-time actions such as a door opening. Overriding animation blueprints, when you need a quick animation without a full system. Key considerations. Does not blend with other animations, it instantly plays. Best for one-time actions. For smooth blending, use an animation blueprint. If looping is off, the animation will stop once it finishes. Would you like an example of using it for an NPC interaction?
Explain to me stop animation node.
Sure. The stop animation node in Unreal Engine is used to halt an animation playing on a skeletal mesh component. How it works. You provide target, skeletal mesh component, the character or object that is currently playing an animation. When executed, it immediately stops the animation that was playing. When to use it. Canceling an animation mid-play, like stopping a waving gesture if an NPC is interrupted. Switching animations manually when you want to stop one action before playing another. Disabling looping animations, like stopping a door from continuously opening-closing. Key considerations. Only works if the animation was started using play animation. If the actor uses an animation blueprint, stopping the animation might not work unless overridden. The skeletal mesh will stay in the last frame of the animation unless a new one is played. Would you like an example of stopping an animation on an NPC when the player interacts?
Explain play sound 2D.
Sure. The Play Sound 2D node in Unreal Engine plays a sound without being affected by the 3D world. This means the sound will play at full volume, no matter where the player is. How it works. You provide sound asset, the sound effect or music to play. Volume multiplier controls how loud the sound is, 1.0 equals normal, 0.5 is half, 2 point double. Pitch multiplier adjusts playback speed, 1 point's normal, 2.0 is twice as fast. Start time lets you play the sound from a specific timestamp instead of the beginning. When to use it. UI sounds like button clicks or menu navigation. Background music, since it needs to stay consistent regardless of player position. Notifications and alerts, like a level up chime or a game over sound. Key considerations. Not positional. The sound plays equally everywhere, unlike play sound at location. Cannot be spatialized. If you need the sound to feel like it's coming from a direction, use 3D sound instead. If you need to loop the sound, use an audio component instead. Would you like an example of how to use this for UI sound effects?
Explain to me apply point damage node.
Sure. The Apply Point Damage node in Unreal Engine is used to apply damage at a specific location on an actor, making it ideal for things like bullets, melee hits, or precision-based attacks. How it works. You provide damaged actor, the actor that will receive the damage. Damage amount, how much damage to apply. Hit from direction, the direction the attack came from, useful for knockback effects. Hit info, a structure containing details like impact, location, and surface normal. Event instigator, the controller responsible for the attack, usually the player. Damage causer, the object causing the damage, like a bullet or sword. When executed, the damaged actor receives an event point damage in its blueprint, allowing you to handle things like health reduction or visual effects. When to use it. Shooting mechanics, applying damage at the exact bullet hit location. Melee combat, dealing damage where a sword or fist lands. Destructible objects, breaking glass or wood at the point of impact. Key considerations. The damaged actor must have an event point damage in its blueprint to handle the damage. If you don't need a precise hit location, use apply damage instead. Works well with line trace by channel to detect where the bullet or attack lands. Would you like an example of how to set up a hit detection system using this?
Explain to me enable input node.
Sure. The Enable Input node in Unreal Engine allows an actor to receive player input, even if it's not the player's main controlled character. How it works. You provide target, the actor you want to enable input for. Player controller, the controller that will send input, usually the player's controller. Once enabled, the actor can detect key presses, mouse clicks, or gamepad inputs. When to use it. Interacting with objects like doors, levers, or computers. Giving input control to NPCs or objects, like letting a turret aim with player input. Temporary input changes, such as allowing input during a cutscene or special event. Key considerations. The actor must have an input action or input axis event set up to respond to key presses. If multiple actors have input enabled, they may conflict with each other. You might need to use disable input when the interaction ends. Would you like an example of how to use it for a door interaction?
Explain to me disable input.
It looks like you meant disable input or another similar node. Could you clarify what disable M refers to? If you're asking about disable input, I can explain how it works. Let me know what you're looking for.
Disable input.
Sure. The disable input node in Unreal Engine is used to stop an actor from receiving player input after it has been enabled. How it works: you provide target, actor or component, the object you want to stop receiving input, player controller, the controller that was previously enabling input. Once executed, the actor will no longer detect key presses, mouse clicks, or gamepad inputs. When to use it: after an interaction is complete, like when a player finishes using a door, lever, or console. During cutscenes or scripted events, to prevent unwanted movement or actions. For temporary restrictions, like disabling movement when a menu opens. Key considerations: it only works if the actor had enable input activated beforehand. Be sure to re-enable input when needed to avoid making the player stuck. If the actor is the player character, it will stop moving or acting entirely. Would you like an example of how to use it in an interaction system?
Explain to me add relative location. Add relative location.
Sure. The add relative location node in Unreal Engine moves an actor or component relative to its parent's coordinate system. How it works: you provide target, actor or component, the object that will move. Delta location XYZ, the amount to move the object in local space. Sweep, if enabled, it checks for collisions while moving. Teleport, if enabled, it moves the object instantly, ignoring physics. When to use it: for smooth local movement, like shifting a door forward. For moving an attached object, like adjusting a weapon position on a character's hand. For physics-friendly motion, like animating a floating platform. And at key considerations: moves relative to the parent, so if the parent rotates, the movement follows that direction. If you need world space movement, use add world location instead. Works well with timelines or tick for continuous movement. Would you like an example of moving an object smoothly over time?
Explain to me game save to slot node.
You already asked about save game to slot, and I explained how it works. If you need a refresher or more details, just let me know.
Repeat after me. These nodes help with interaction physics, animation, audio, damage, and saving data.
These nodes help with interaction, physics, animation, audio, damage, and saving data.
Repeat after me. I hope you had a good time watching my video. I worked really hard for it. Follow, like, and subscribe, and I'll make more videos.
I hope you had a good time watching my video. I worked really hard for it. Follow, like, and subscribe, and I'll make more videos.